Testing 1, 2, 3. Alright, I'm back. So, I had to do a change of plans with the nuclear factory design. I discovered, or I should say, well, whoops, I don't want to do that. So I started doing a spreadsheet for the lines that we're going to be using, and I discovered that there's not enough room on the sushi line, sorry, 4 sushi lines to do all of the manufacturing of parts as we go up the stack, because right off the bat you have petroleum coke, plastic, and rubber that are first generated on the stack. This is I believe this is the first stack on, or manufacturing stack, or sorry, factory stack, right above the particle accelerator, because there's a lot of blueprints that require this creation of parts that allow us to have significant reduction. So this is ignoring things like yttrium or copper, crystal, or iron, because either they don't contribute much gain or loss, or they contribute a whole lot. But other things like steel, which help us get reductions, still require petroleum coke, plastic, and rubber to begin with. And so because there's so much dependency to get started with this factory from the oil, it seems logical that we have to start with this first. However, you quickly realize that there's a problem. You tally up all of the items that are created versus destroyed in this oil blueprint that is established, it immediately adds up to almost a Mark V belt worth of stuff. That 958 parts per minute. That is something that I cannot easily load onto these sushi lines, because what's worse about these recipes is that they are using packaged oil to create these parts, which means that we're not only are we not subtracting anything from the sushi lines, but we are creating a substantial amount of parts, and these parts are very important for other recipes down the road right off the bat. So there was just no feasible way that I could, continue designing this factory without adding a 5th sushi line. So that's exactly what is being illustrated here in this diagram. Sorry, in this spreadsheet. So this is going to be a very boring stream, unfortunately, but what I'm going to do is I'm going to be mostly going through the spreadsheet and using this calculator to tally up all the parts that are being loaded and offloaded off of the sushi lines to make sure that we never exceed capacity at any given floor stack. And then once I've verified that is the case, we will continue the design of the factory. Oh, thanks Tam for joining, I appreciate it. I'm giving a lecture on what I did wrong and what I'm going to do better next time. So yeah, but I was trying to figure out how to redesign the stackable blueprints to compensate for a fifth sushi line, and what I've done here to compensate was um, I took all the 4 dedicated lines in the factory and I've collapsed them together like this, very similarly to how we've collapsed the water lines to make more room. But I've spread out, but I gain an extra spot for the 5th sushi line, and now I have 5 sushi lines on the blueprint now. And I had to compress these lines here as well to compensate. But the water manifold hasn't changed. That's still the same, at least structurally. I did change the water line to change the characteristics of the overflow and the any ports. So I set up the water lines so that the water is forced to go up the stack before it goes onto the mergers to hydrate the reactor. I realize that is sort of a necessity for this design because we will also be using 4 of these lines further up the factory stack to hydrate the factory. So I'm reprioritizing the flow to compensate for that because I was worried that there might be a scenario where the factory is not getting hydrated because things are getting rerouted in different directions as a result. Although I haven't actually, that reminds me, I need to actually change. I was trying to decide on what the flow for these splitters should be. Okay, I think oh, actually, that reminds me, there's something else I need to check. Oh, no, these are all the same, I think. It's just these ones that are different. Let me go down here and fix that. Yeah, this is a bit confusing. The orientation on this one is... Okay, so... Alright. Oh, it's gonna be like this. So we immediately go down the stack before we divert stuff over part of the manifold. This one is going to be overflow like this. Going like this. Yeah, I can't copy and paste these, because if I do that, then it just overwrites stuff, which is not what I want. Or not overwrite, it just adds or appends. Not what I want. I want to overwrite it. So this also means that I gotta redo the water line. Well, now, or sorry, retest the water line and make sure the water line is fine. But yeah, something that I was heavily contemplating on doing, and I kind of chickened out on doing, was to reposition the reactor to face in the other direction. So the reactor is facing the water lines, and the light source is going through this slit in the blueprint. And the reason why I wanted to do that was because that would force me to reorient the factory blueprints so that the particle accelerator is facing forward so that you can actually see the rings on the front side of the plant. And I kind of chickened out on that because that would require a substantial amount of reworking I would have to do. I essentially would have to either redesign this entire reactor rigging, rigging for the packagers, or I would have to delete all of this water stuff. And I was like, and on top of that, I would also have to redesign all of this stuff over there. All that logistics would have to be redone. And it wasn't clear to me if there was going to be enough space to do that, because essentially what would happen is the all 16 belts of water would have to circle around the stack in order to twist, to compensate for that twist of 180 degrees. And I was like, yeah, that's a lot of work. I don't really feel like doing that. So yeah, I'm probably not going to do that, but yeah, that is an unfortunate design oversight on my part. But if I ever design this system, I'll try to keep that in mind next time. Camera turned off again. Happened. That's unfortunate. I'm trying to fix my VTuber model right now. I'm trying to fix my camera because it turned off again. I don't know if you can hear me, Tam, but I'm not entirely sure what causing this to happen. Alright, unfortunately I can't figure out causing the camera to not turn on. It's alright. Alright, I guess we'll just... No. Yeah, something else that we gotta keep in mind is that we have a... Not only do we have a budget on the amount of stuff on each sushi line, but we also have a budget on the total number of stacks, blueprint stacks. Because if you're building this factory at sea level using blueprints, and you're stacking them all the way up to the ceiling, you have to build the entire stack using no more than 49 stacks, because if you go above that, you hit the skybox. We can go 6 stacks higher if we build down there at the bottom of the island to push even further, but I think we should be fine. Yep. Alright. So right off the bat, we already have the alternate rubber, what does it say? Alternate rubber, recycled rubber. Alternate recycled rubber, packaged water and Coke. We have recycled rubber. Is that it? We also went with the blender diluted fuel instead of the binary diluted fuel because I was able to get that to fit inside of a blueprint. Okay, where is diluted fuel? So all of this is in a blueprint, and the way and to make this easier on me, I basically said that, yeah, so we're gonna put all this in a blueprint, and then we're gonna make multiple copies, and because we're overclocking everything, we'll have one of each of these in the blueprint. Actually, I think I made that blueprint. I can show it to you. I was already working on this blueprint already. See if I can get everything to fit inside. So here we have the diluted fuel, we have the unpackaged oil, the should be unpackaged water. Yeah, I'm gonna have to redo these logistics. Okay, and then we have the rubber, petroleum coke, the alternate recycled rubber, alternate recycled plastic. So I was able to get all this in a blueprint, but I'm still gonna have to hook up all the logistics to get this to work. So it's finished yet. Okay, so that's all one blueprint, and we're internalizing all of this into one blueprint because we're getting rid of the because we don't have a line for the fuel. That's why the fuel is required here. So that's why we are completely, and the heavy oil residue. Those are both fluids, so we don't have a dedicated line for. So that's why we are internalizing and then underclocking, and then making multiple copies. So because this refinery has the highest number of buildings, we're going to make 4 copies of everything. Okay, so we're going to take 8.338. And we're going to divide that by 2.5, we're going to divide that by 4, and that gives us an overclock for that refinery of 2.085845, and that is something we can do with powder shard. So that's where that number 4 comes from. Okay, so this is all grouped into one blueprint. Okay, so in our spreadsheet, we have a stack size of 4, so we're consuming 4 stacks right off the bat with these blueprint. And we're not taking anything off the sushi line because we are using the dedicated line of packaged oil, and then we're magically creating 3 new items: petroleum coke, plastic, and rubber, with this amount. And I set up a spreadsheet so that it'll tally up everything super easy. And as I said earlier, because we don't have enough room on these sushi lines, we're going to make a 5th sushi line and plop it onto this 5th sushi line here. And now I have a new sum total. So this is the formula that I'm using to sum everything up here. Summing up all of these elements. So, yeah, so all the items. This is the item column, so we're going to put an item here, and then if we cross-reference which sushi line we're adding it to, and then we have the net accumulated at any given moment on these columns here. So the goal of this game is to make sure that we don't go over a 780, which is which is the capacity of each line. So that's kind of the game we're playing right now. Alright, so that's cool. Alright, so the next recipe down the stack, up the stack I mean, is the alternate molded beam, the alternate molded steel pipe, alternate coke steel ingot, and the alternate rubber concrete. So we're going to grab those. Okay, I have 4 recipes. Is that how many do we have? 1, 2, 3, 4. Okay, so I put all of these in a blueprint. I think I should be able to fit all of this in here because this is 2 assemblers, this is 2 foundries, this is 2 foundries. So there's 5 foundries and 2 assemblers in this blueprint, and I believe that I should be able to get that to fit into one blueprint. Okay, so that's all a blueprint here. I guess I could make this more visually understandable if I just put these of this one, better visual appearance. Okay. All right, cool. All right, so and as we can see here, we are producing concrete. We are consuming iron ore, which the iron ore was loaded onto this sushi line right here. I'm also using this specified order that was previously established. These items already. So sushi line 1 has iron and deuterium. Sushi line 2 has sulfur and uranium. Sushi line 4 has bauxite, crystal, and copper. And sushi line 5 has limestone. Or sorry, no, my bad. Sushi line 3 has bauxite, crystal, and copper. And sushi line 4 has limestone. Okay, my bad. Alright, so let's go back to the spreadsheet here. So yeah, so some of these recipes, so both of these recipes, the molded recipes, are both consuming concrete. We're also producing some steel, and then we're consuming that steel all internally in this blueprint, and then we're generating steel pipe, steel beams. We're also consuming rubber as well to generate this concrete. So overall, we get a net reduction across the board, okay? So we're making room for other stuff down the line, which is super important. All right, now the next question I was trying to I need to figure out is what is the next thing we're going to build? So the next thing that we could tackle is, I think it was this. It was the fused uranium cell. We can actually tackle that right off the bat. I think that requires 400 silica. Actually, that's a good question. Where does all that silica go? A lot of silica. $180 of it goes in non-fissile uranium, 180 goes in alternate fuel cell, 90 goes to aluminum ingot, Well, actually, I don't know what we should be using. So one particular problem that I think we're gonna run into right off the bat is we're gonna have a major slowdown in the transient response of turning the factory on from the factory on its own, because the factory requires petroleum coke be fed to um needs to be fed to this blueprint, this electrode scrap, but it needs a tiny amount, um, which is like 21.6 per minute, which means that at 21.6 per minute, we have to fill up all of the last buffer here at 21.6 per minute, and that's going to cause a slowdown in starting up the factory. Um, yeah. Yeah, there's another slowdown here, which is the pure iron ingot. This is also going to give us a slowdown because this will only, yeah, this is going to be a major, this is a huge slowdown because this requires 9.6 iron per minute, which means that the buffers for this thing are going to also slow us down by at least filling up the last buffer by 9.6 per minute. So that's also another slowdown. Factory, yeah, this is also something that has to be made. Uh, yeah, and then we're producing this massive amount of silica. Pretty insane. A lot of silica. Yeah, I'm just grouping all of these together because these are relatively small blueprints that I would like to get done as early as possible, but like I can't get them done faster than than uh, oh, actually, I think we can move these down here. Actually, I think we can do that. I don't think that would be a too much stretch. We're missing something here. Oh no. Oh crap. Oh yeah, that's not gonna work. I forgot. There's a quartz crystal blueprint somewhere. Yeah, I don't think we're gonna be able to get all of these in one blueprint. That's 4 refineries. Oh wait, hold on. No, we can do that. Hold on a second. 2, 3, 4. Okay, never mind. Yeah, well, I take it back. We can get all of these done in one blueprint. So actually, let's knock this out, because if we can get this done early, that actually speeds up the factory transient response, because these are the slowest producing stuff of initial stuff. And yeah, that'll give us a massive speed up if we get these knocked out first. So yeah, that's definitely doable. We can actually do this. Alright, so I'm gonna we'll put it down here, I guess. All right. So what do we have? We have alternate pure quartz. So this requires raw quartz, and where's raw quartz? Raw quartz is on line 3. So we are going to subtract that amount from that line. Okay, good. What is next? Iron ore. So for iron ore, we have uh, subtract negative 9.6. Good. Okay, what is next? We have alternate coated iron plate. Okay. Done. This is uh, 'Alright, so we produced 72 quartz crystal. 36. Alright, plastic. One stack. Okay, is that it? Oh, that's right, bauxite. So for bauxite, we're going to use up that amount of bauxite. Alright, oh crap. I forgot, this requires... I forgot about that. Well... Oh wait, never mind. It's just this. Requires it. Okay, never mind. So we're producing 27 silica. And we are consuming negative 12.6 petroleum coke. And $108 aluminum scrap. Alright, so yeah, that's pretty much it. Alright. So what's really cool about how I set up the spreadsheet, again, if I haven't mentioned this before, is that once I've established where everything goes item-wise, I can just quickly go, oh, that doesn't work. We're clearly over capacity, but like I can just move stuff like this. Okay, so now this has gone down and this has gone up. I can actually probably just move all of this over here, right? Oh no, I can't. Okay. So here's me redistributing things. I'm playing this redistributing game to make this work. Yep, look at that. We're just barely over the limit there. Yeah, this is internalized, so this doesn't matter. So I just picked a distribution where we're putting iron plates and quartz crystal on line. Actually, you know what we should do? Probably group things up according to input, so put those together. Iron ore, iron plate, so those are grouped up. What is this? Plastic. Oh, that's this. Plastic. Plastic is here. Oh, I forgot about that. I already made a mistake. Plastic has to come off of this line right here. So I wasn't even paying attention. Are we using petroleum coke? Yes, we are. So I have to subtract it from this part of the line right here. Okay. So aluminum scrap. Where's bauxite? Bauxite is here. Okay, so those are together. Silica. Where's crystal? Put this there. Okay, so quartz crystals lined up with raw quartz. Iron ore is lined up with iron plate. Silica should be lined up with raw quartz. We have petroleum coke, and then we have aluminum scrap, which is lined up with the bauxite. Okay, so let's check our lines here. Boom, 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 and a boom. Okay, so we are good. We are still under capacity. That's good. Right. So yeah, by knocking this blueprint out early, we reduce uh, we reduce uh, the startup time of the factory, but we're still under budget for so that's good. All right, so that was pretty dope. Okay, so we got that done. Right. So the next blueprint, I guess we could take a look at. So we could do the bad thing and have this be towards the end of the stack, but I guess that's totally fine. It's like it's 90 silica per minute, so that means that the last buffer is gonna fill up in 1 minute. So it's still not great, but it's not like waiting 10 minutes for a buffer to fill up, you know? That's kind of the difference there. Alright, so the next troublesome blueprints are these ones, which I have no idea if we can actually fit these in a blueprint. So, where is it? Oh, it was the quick wire. Fused quick wire, where is that? Um, so the fused quick wire is the worst recipe. Or sorry, quick wire is usually the worst item in any nuclear power plant when you're building a stack, because you're producing an insane amount of it. So we're producing 1,530 quick wire per minute. So yeah, we're definitely not putting that on the stack. However, we do have some other really bad things happening here. Like for example, we have copper ingots. We're taking away 300 copper ore per minute and turning that into 748 copper ingots. So we're effectively adding 450 items from that recipe. And then for deuterium, we do have a subtraction. So we are putting 300 deuterium ore on, we're taking 150 off, so that's a negative 150. So these two combined is an effective plus 300, so that's still not great. And then we have this thing, which is taking 181 rock crystal and 300 limestone, and it's converting it into 423 silica. So yeah. That's not great. Or no, that's actually good. No, it doesn't do anything. Or no, it's a slight negative, but like it's not substantial. So the thing I'm not sure about here, I wasn't sure about is, oh yeah, so the reason why I'm grouping these together is because the quick wire is only used by the plastic AI limiter and the infused uranium cell. Okay, that's the only time that it's used. So the question here is, can we group all of this together? Now, this is very strange to see this manufacturer this early in the stack. However, I discovered that, or this is something that is kind of known, but like I didn't really see it. I never really done it this way, which is we could put the infused uranium cells pretty early in the stack because it only requires uranium, silica, sulfur, and quick wire. Those are relatively early items, so we can easily knock this out of the park, or sorry, knock it out right now. But I wanted to verify if we can actually get this to fit in the blueprint, because if we were to fit this in the blueprint, we would essentially have, uh, yeah, we would have 2 refineries, 1 manufacturer, and 3 assemblers. Okay. Essentially, and the number of stacks would be insane. I think the last time I calculated this was 8. This would be, there'd be 8 of these, and this is gonna be quick. This is, yeah, this is the quick wire. All right. So we're going to simulate this. See how bad this is going to be. Can we actually get all of this to fit? Is the question. Oh, that's a good point. How many manufacturers are we gonna use? Just double check my math here. We're gonna have 19.957. Divide this by 8. So it gives us an overclock of 2.49. So if we have 12, that is 1.5. Okay. No, that's 1 manufacturer. Okay. Alright, so that's totally fine. That's totally doable. Yeah, so that means, what about the fused quick wire? Oh wait, never mind, sorry. I keep forgetting this. When you're duplicating blueprints, you only have 1 copy of each. I keep forgetting that rule. Okay. Alright, so, oh, I forgot to mention this. When we're duplicating blueprints, you also have to make sure that you don't underclock too much, because the lowest underclock that is possible in the game is 1%. I forgot to mention that. So we need to make sure we do not underclock anything below 1%. All right. So, yep. Okay, so that fits. That is good. Then we have 1, 2 assemblers, which I should be able to get that to fit. There's 3 assemblers. Okay, so that's not what it's gonna look like, but it's just an approximation here we're doing. Yeah, this is definitely doable. We can definitely do. I'm confident that I can get that to fit. And then we're gonna have 8 of these, which is significantly consuming our budget here. Stack budget. Yeah, that's fine. Alright. Okay. So we are going to put this in our spreadsheet. So this is going to give us hopefully a massive reduction. In terms of things being used. We're going to this thing. I already started tallying things up for this. Okay. We're gonna use the alternate fuel rod. Correct. Oh, we're gonna make some AI limiters. Alternate. Plastic AI limiter. Going to make some. We're gonna make some cheap silica. We're gonna make some. Put there. And what else? Okay. So those are all those recipes. Alright, now I need to start tallying things up here. Alright. Oh, this has stack size of 1, so this is gonna have stack size of 8. Okay. And where's copper ore? So copper ore is line 3. Okay. Caterium ore is line 1. Okay, that's good. And I guess we could put copper ingots there, and we'll put caterium ingots there. Okay. Alright. And, okay, so quick wire. So for quick wire, all internalized. Okay, for quick wire, oh, sorry. For quick wire, we are producing a whopping 1,530 quick wire. Okay. However, we are consuming minus. Sorry. We're consuming that much copper ingots. Oh, this is another bad one. Okay. Yeah, we're gonna fill up a buffer down the stream, or up the stack. That's gonna be as low, up and running. Oh crap. Yeah, this is bad. Okay, yeah, I'm gonna have to fix this. This is a really low number. So, yeah, the alternate fused wire is gonna be slow starting up. Pushing this later in the stack. Where's your aim is line? And then we have silica. Producing 423 silica here. So is that it? Silica requires quartz crystal. Raw quartz. Okay. Raw quartz again. Cerium ingot. Copper. Copper is line 3. Okay, and we're also producing uranium cell. Producing base uranium cell. And we'll put it on the uranium line, which is right here. Oh. Whoops. So I didn't, I'm glad I caught that. Okay. For some reason this is not auto-adjusting. Okay, so that looks good. Alright, so I think that's everything. In case uranium cell, rock crystal. Actually, let's just. We have Caterium ore. We have Caterium ingot. Yeah, this is kind of hard to read. Oh, we need sulfur. Whoops. So we need 300 sulfur. Yeah, that's gonna be a massive drop. Right, we are cooking. Okay, in case uranium cell. Wait, no, this is the wrong. We need, oh no, I guess that silica wasn't tallied. Okay, so we um, need 100, minus 180 silica. Okay, we need minus 300 sulfur, minus 190 quick wire, minus 100 uranium ore, just 240. That's what I wanted. All right. Okay, that's good. All right, so now we have silica. Um, have, oh wow, we're still missing stuff. Let's see. Okay, okay, that's not right. Oh wait, never mind. That is right. So this goes, those group up together, then we have copper ingot. Okay, perfect. All right. So we're missing AI limiters. Where's plastic again? Plastic is on line 5. And, okay, and we're going to act that, okay. Going to use 42 of that. Okay, so I wanted this together. So AI limiter, how much 30 quick wire. So 730 quick wire, okay, good. And then we have have 150 quick wire, which comes from these. Have Alright, so this is much easier to read now. Up all these different recipes. Do the same for yeah, so I just reorganized everything so it's easier to read. This is all internalized, so it doesn't matter. Alright. So this is looking good. Alright, this is great. Okay, now there was a problem I discovered. This, well, wait a minute, hold on. Well, I guess we could. Tight fit. Probably make it work. $74.88, okay. So yeah, so we can't put the wire on this line, because that puts us over. But what I can do is put it on this line here, okay? So yeah, that will work. So yeah, we're loading an explosive amount of wire onto the sushi line. But that does eliminate the slowdown from filling up the buffers now. Because of that. Okay. But yeah, this will be a tight fit, because now we have 4 assemblers. We have 4 assemblers that have to fit in there now. Alright. Yep, and then we have 8 copies of this blueprint. Okay, so we're doing good. think. AI limiters. Alright. What is next on the list? Things to do. Well, I guess we can go after, stators, rotors. Could do it. Hmm. Yeah, we could also do. No, I think we should leave this last. I think. Yeah, yeah. Okay, that's right. Yeah, we usually do this last. I forgot. All right. Okay. Yeah, we already did the particle accelerator. So we have these. We have the. All right. So what is this? So we have... Okay, so these assemblers, so there's 3 of these assemblers, we have 2 of these assemblers, we have one additional assembler boundary. Yeah, this is all, I think we could fit all of that in there. And then, yeah, this is all subject to change later, I guess, in the design. But yeah, we could do I think we could probably get these together, because this is, well, no, actually, hold on. Yeah, sorry. Okay. So this, yeah, this is 5. This is, wait, no, that's not right. 6 manufacturers. Okay. There's 6 of these. Yeah, okay, so yeah, we would have to divide this into 2 blueprints. So this would be 3. This would be 1. So I have been able to get, so you can get 3 manufacturers plus 1. You can do that. And then you'd have to put these 2 assemblers on top of the crystal manufacturer. That to work. But like, this is subject to change, because like, for example, I could probably move this thing down here, you know, as an example. Oh no, wait a minute, hold on, no, this is way more than that. This is... Okay, so that would be one assembler. So that, yeah, so I could move this thing up and down, you know, like I have that flexibility. Then the next set of blueprints is going to be the acid blueprint, which we'll put up here. Which I think this blueprint has room for more stuff that I can put in there. And then the last blueprint is going to be this thing on top. The reason why these 2 are on top of the stack is because the way that I've designed the blueprints, or I should say the way that I designed the dedicated lines, which are these ones right here, is that because the particle accelerator and the reactors are on the bottom of the stack, and the recycling facility and the uranium rods and the rods are on the top of the stack, what that does is it creates this really cool visual effect of seeing all the radioactive parts go completely up and down the stack, which I really like that visual. As opposed to like bringing them close together and you don't see them a whole lot. That's purely like the only reason why I'm doing that. If I literally brought these buildings much closer together, I probably could have internalized them. Yep. Okay. So we're going to go down this list here. so we have some stators, we have some steel pipe, have some wire. We are producing 52.2 stators. We are consuming 107.6 wire, and we are consuming negative 506 points pipe. Okay. The next one we have rotors, and we are consuming 24 of those. We have some wire here, and we have steel pipe. So for steel pipe, we are consuming negative 144. Sorry, for wire it's a negative 144, and for steel it's minus 48. Okay. Then for aluminum ingot, which honestly, I feel like probably put this somewhere else, right? So for aluminum ingot, is aluminum. Which consumes 90 silica and aluminum scrap. It consumes minus 108 scrap. It produces 72 aluminum ingots. Okay, and then we have alclad casing. So this so this is aluminum casing, and we are producing 54 of those. Are consuming minus 36. Minus 72. Okay. So this is all in a blueprint. Actually, let me swap the order of these. Okay. It's all in a blueprint. And let's go grab those recipe names. Okay, we're using this. Okay, I think we're just we're using stators. We are using one, two, four. blueprints. Good. There's only one of these blueprints. I think we can fit all of that. Okay. So now I just go. I have to put all of these in the right order. Alright, so steel pipe is located on J. Wire located on F. Okay. Wire is there. Steel pipe is there. Pipe, okay. And copper ingot is here. Sorry, aluminum scrap. Aluminum scrap is H. Okay. And silica is H. Scrap is there. Okay. Okay. For rotor. So yeah, I mean, what's going now? The reason why we are building the factory with not using load balancers on the sushi lines is because it reduces the amount of splitters and mergers that I have to assemble in a given blueprint. Because we are specifically not redistributing everything equally on the sushi lines, we don't have to build like massive splitter merger arrays to pull and extract things off of each one. But that does mean that we have to manually keep track of what is put on and off the sushi lines. That's the penalty that we pay. But so that's a lot more mental burden on my part as the designer of the blueprints, but that's less of a burden on the user because they don't have to spawn so many different elements into the blueprint. Obviously, this is kind of a bad example but that's totally fine because what's most likely going to happen with the reactor is the reactor is going to be redone anyway after the entire plant is built, because what I'm going to do after that is I'm going to go back and I'm going to make individual blueprints for each of the numbered reactors 1 through 15. Each one is going to have a much more cut down water manifold, and each one is going to have its own dedicated load balancing manifold for the rods and the uranium waste to speed up the reactor startup time. But that's much later after everything is built. Will I ever pursue that endeavor? Because this is like the bare minimum product. Can we get this thing up and running? You know, and that is not necessary right now for getting things up and running at this time. Okay, whoops. I made a mistake. Okay, I'm not sure what just happened there. Okay, that's big. Not sure what happened there. Alright, my bad. Okay. My bad. Alright. What is next here? Hmm. So yeah, what's nice about this spreadsheet is it offers me the flexibility to dynamically move stuff on the different sushi lines, because what's really not nice is, you know, you get later up the stack and then you realize that a bunch of items that you need are on the same sushi line. When that happens, you have to build like a smart splitter array that essentially filters out everything that you need to get pulled off of that sushi line, and then you have to hook in a return line that's called the overflow line back onto the sushi line. And that's, I mean, that's technically possible, but like, it's not ideal. It's not fun. It's way better just to be like, oh, all the items I need are all on separate lines. So I literally just, you know, plot, put down different programmable splitters, and I'm done. I don't have to worry about that. All right. So we're getting close to being done here. What is the next thing here? Okay, so we have the heat exchanger. So again, everything is looking good here. Everything's looking good there. Everything is looking good there. Everything looks good here. Although that's a bit suspicious. Wait, no, something's not right here. This is 780. Oh, never mind. I was worried there was something wrong here. Never mind. Yep, so that's good. That's good. So yeah, they're all below 780, below 780. Yep. So we're doing good. The numbers are going down. Okay. All right. So for the next one, we have heatsink, which requires 18 produced. Oh, oh yeah, that's bad. 54. So that's bad. So this means that this rubber has to fill up all of the rubber buffers before it. Not ideal. Okay, and this is alright, so the next one is crystal oscillator. Called oscillator. And we're producing 7.2 of those. And we are consuming 7.2 AI limiters. Oh no, this isn't too bad. Since these are in the same blueprint, then we have more rubber coming in from another building, so that's not too bad. Okay, so minus 50.4 rubber. We have minus 72 quartz crystal. Okay, perfect. Like it. Okay, what is the next one? Next one is uranium. Full. Rod. Okay. So that should be the magic number of 7.2. Zooms. Minus 24 rotor. Zooms. Negative 7.2 crystal oscillator. Have magnetic roll rod. Okay, perfect. And then we have electromagnetic control rods, which consume stators and AI limiters. So we have 34.8 electromagnetic control rods. We have minus 34.8 AI limiters. And we have we have minus 52.2 stators. Okay. And how many? I think this was 2. So I think you can fit 2 of these. Fit 2 of these. Back. Okay. Let's grab these recipe names. So we're gonna look. Have alternate uranium fused rod. What else? We have electromagnetic control rod. We have alternate insulated crystal oscillator. And the last one is heatsink. I believe we can do this in 2 blueprints. Okay. Alright, so that's good. Now I just need to figure out where everything is going to be loaded onto the stack. So where are the AI limiters? AI limiters are J. Okay, rubber. I think the rubber is supposed to be there. Aluminum casing. Casing is H. Aluminum casing. Crystal oscillator. Okay, where's the quartz crystal? Quartz crystal is H. Oh, that's right. Sorry. This is not included. Okay, where are the rotors? Rotors are I. Okay. Electromagnetic control rod. Guess it doesn't matter. And where are the stators again? Stators are J. Okay. Alright, cool. So we're gonna be doing a sanity check. We're gonna put a final checksum at the bottom here. Where everything has to add up to 0, I think. That's a way for me to check for mistakes. Okay, so the next set of blueprints are the non-fissile uranium, the sulfuric acid, nitric acid, and that doesn't count. And that doesn't count. Alright, so we're gonna do these. Alright, so we have silica. We are consuming negative 180 silica. And that's it. Okay. Then we have sulfur. We're consuming negative 108 sulfur. Then for the nitric acid, we are consuming negative 36 iron plate. Okay, I think that's it. Alright, so let's... we're gonna put all the recipes here. Okay, we have nitric acid, we have... whoop, oh, that's not right. Non-fissile uranium, and then we have uric acid. Okay. And I should be able to do this in 3 blueprints the last time I... Yeah, three blueprints. Okay. Alright. Okay. We're gonna move those up like this. And then we're going to put the total here and okay, where's the silica? Silica is in H. Okay, where's the sulfur? Sulfur is line G, it's in G, okay. There, and where is iron plate? I don't remember where. Iron plate is F, okay. Alright, beautiful. The numbers are going down, okay. Alright, last blueprints, we have 3 manufacturers. And, I don't know how many that is. How many is that? we have 5. Let's divide by 5. Yep. Then we have 5 assemblers. I don't know if I can fit that in a blueprint. That's literally a tall order. Alright, we need to verify that. I think we can get that to fit in a blueprint. But we're going to double check. So fun fact, I made a bunch of stackable blueprints. Alright, we're gonna grab the assembler. Not the assembler, the particle accelerator. Where is that? Right here. And we're going to rename this as no. Okay. I gotta delete a bunch of stuff. Is that it? Alright, so we're going to double check to make sure that I can actually fit all this in here. So I think, yeah, we should probably do the assembler, because I don't know if we can fit. I don't know if I can fit. This, and we need this, okay. So, we're gonna put this here. So, yeah, I've done this before. So we can fit 3 of these stack, okay, but I'll just quickly demonstrate that here for the non-believers. Oh, sorry. So yeah, I'm also demoing what this is gonna look like when we actually do designer decor. So when we do designer decor, we're going to be putting these inputs flush against the back wall as much as I can for all the buildings, and then we're going to design decor around them so that we can still see stuff moving internally on the outside of the blueprint. Okay, because I'm a big believer in seeing stuff move in your factory when you're designing decor architecture. Believe that your decor should not be hiding stuff dynamically happening in the factory. That's my personal opinion. Alright, so yeah, that's just a quick demonstration that we can fit 3 manufacturers in this blueprint, which is exactly what we need. But now the thing I'm not sure about is the assemblers, because I don't think you can fit 5. Is that, did we say it was 5? Yeah, 5 assemblers. I don't think that's possible. But I'm going to quickly double check, just to be safe. Nope, that's not right. So again, we are making this flush against the thing like this. Okay. Then we are going to put this. I want to say you can only fit 4 of these back. Fit 5. Okay. So I cannot fit 5. We can only fit 4 assemblers in a stack. However, I don't think that really matters because there's plenty of room elsewhere here in this. Yeah, we could easily put one here. Okay. Yeah, so this is not that big of a deal. Okay. So yeah, we can definitely put 5 assemblers and 3 manufacturers in this blueprint, no problem. Thanks to my stacking manifold. For those who haven't seen this stacking technique, you can see that we can easily connect blueprints together like this, and then they feed right into the building. I've been doing this for many moons, and I've been optimizing and changing how we can stack these buildings together. This is the newest iteration of design that I've made, where we're using a very special technique to compactify the splitters and the mergers to take up the least amount of vertical space possible, to expose as much of the vertical lift as possible. And we're going to be feeding from the top, okay, for the inputs, and then we're going to be extracting from the top from the outputs, okay, and then we're going to feed those right back onto the lines. And because I designed these new template blueprints for stackable factories to have dynamically adjustable splitters and mergers on the sushi lines in terms of vertical height, we can move these up and down to accommodate for the height difference with the building, so we can reduce the amount of belts that are going to be shown in the blueprint. So that's a nice little added design feature that I incorporated there. Okay, so that was just a quick sanity check. We can fit all of this in one blueprint. That is good. Okay, so now let's incorporate all of this here. Alright, so we have concrete, and we are consuming negative 216. Okay. And that's it. And have minus 32.4 beam. Negative 10.8, and then we have heat sink. Have minus 18. Okay. That's it. Okay. All right. So we have plutonium fuel rod. We're using the less efficient plutonium fuel rod recipe because that consumes less resources than the other one. And we don't need to produce more plutonium rods for the same amount of uranium waste. We just need to get rid of the uranium waste. So that's why we're using this lower yield plutonium. The other one, paste plutonium cell. Okay. And we could do this in one blueprint, and we're going to here grab. Okay. So where is concrete? I don't remember. I think it's here. Yep. So it's in the I. Okay. Steel beam. Steel beam is in J. Okay, so we're gonna move that into J. Electromagnetic control rod. I. So we're gonna move that into I here. And heatsink hasn't been recorded. Alright, so that's it. Now, that's cool. Now what we're gonna do now, so that's the entire stack. We just stacked all of these blueprints together, and the next thing we're going to do now is we're going to do a checksum. The checksum is just a sanity check to make sure I added up the numbers correctly. Okay. So the checksum is going to be as follows. We're going to take all of these numbers here, down here. So this category is called the total checksum. Alright? So we're going to take, it's the Caterium ore, okay. So we're going to take minus 300 for grab. There you go. So we're going to take the actual used Caterium ore, and then we're going to subtract it from the loaded Caterium ore to get the remainder. So this is the remainder. So we're going to have we're going to have 7.56 ore trickling down the sushi line at the end. So for the checksum, we just simply subtract this from the total. And the goal is for the checksum to be 0 across the board. If it's not 0, that means that I made a math mistake somewhere. Okay, so the next one is iron ore. Okay, so we're gonna put this here. Rack 300. Okay. So that means that we have there's gonna be 79 stuff coming down the line per minute, and so that's gonna be our subtracting thing for checksumming. Okay, so for this one, sulfur. So the sulfur is, where's sulfur? We have 480 sulfur minus 450 sulfur. So we have negative 42 sulfur. Sorry, we have 42 sulfur coming down the line, and I think this is uranium. And yeah, there should be no uranium left. So that's it. That's the entire checksum. So there we have a minus 42 checksum component here. Okay, so we have bauxite. So this is equal to minus 120. So have that. So we have 52.2 bauxite trickling down the Sushi line. Have what's next on the list here? Raw quartz. Okay. So let's put that in the checksum here. So we have plus this minus this. We have okay, so we have 82 stuff coming down this line at the end. And okay, so this is going to be we have so we have 37 limestone coming down the line at the end. Okay. All right, so checksum. I don't. Actually, let's just call this remainder. So we'll call this the nothing. This will be the checksum. Okay. So we're gonna move. Let's put a space. Okay, so the sum of everything here, okay, should be 0. Okay. All right. And oh wow. Okay, so we're clearly a mistake was made somewhere. Wait, rubber. Why is rubber here? Rubber should be. Okay, there should be nothing in this. This right here is the total stack size. Sum of all these values, really. Which is 21. Okay. Add plus 15 reactors, plus 2 particle accelerators, so 38. So Yeah. Total stack size, which is below 49, so that's good. Okay. So yeah, the checksum is definitely not 0. So that means I made a mistake somewhere, so we gotta figure out where that mistake was made. So this is clearly wrong. Why it's wrong though? Adding things up correctly. I have no idea. Hmm. Okay, I think it's because... Yeah, I think it's because we didn't include line. Yeah, this should be the line. Correct. That amount. Okay, 240. Let's take a look. So, case trainings. Oh, that's, wait. That's why. Never included. crystal rotor electromagnetic goes here. Alright. Ooh, look at that. These numbers should cancel. Yeah, iron plate. Coming from there's aluminum casing. Oh no, not aluminum casing, it's copper ingot. Okay, where's copper ingot? Okay, so this is supposed to go here. So we got 3 zeros. Perfect. Okay. What is going on with this one? We have um hmm. This is going to be a much more drawn out process. Oh, actually, wait, hold on a second. Never mind. This should not be negative at all, so that means there's a number here that's not right. Overdrawing on something. How did it get down there? Oak. Concrete is... Okay, pipe. Good, alright, steel B. Iron ingot, or yeah. Iron ingot. Plastic is petroleum coke is 6. Okay, and then rubber is here one. Plastic. All of these individual numbers are correct, but they are adding up to negative. And there's nothing, there's no remainder that we have to subtract from, so I don't know. Is there a number that's like... Okay, how much concrete are we producing? Oh, wait. Oh. There it is. Boom. Okay. So that solves that problem. Alright. So now we have too much stuff on this line. 175 of extra stuff. Alright, so it looks like plastic. Those numbers don't add up to 200. Oh, I forgot about that. Oh. Okay, well. We forgot about the fact that we're recycling. Okay, well. That. And let's grab the rubber here. Rubber. Boom. We have a checksum of 0. Okay, so there's a very high chance that we've done everything correctly. Nice. Okay. That's awesome. So, what this means is that if I get sloppy and I do something like this, boom, like that, I'll go down here and go, oopsie daisies, let me go fix that. Oopsie daisy. Okay, we're good, we're good. Checksum has been validated. And we're going to check the numbers here too. Alright, so we're going to go down the production line here. We're going to double check the numbers on this side. So these are within the limit. These are within the limit. These are within the limit. These are in the limit. These are in the limit. These are in the limit. Perfect. Alright, this is satisfying. No pun intended. And yeah, it's gonna be 38 stacks tall. Alright, yeah. So I'm glad that we did this. This was very boring, I know. I apologize, but was super important that we did this calculation because even though it took me like 3 hours to finish it. So yeah. Yeah, so we verified that we can build the entire nuclear power plant only using 5 sushi lines. That's amazing, okay? And we have an exact formula for doing that, okay? An exact procedure that we have to follow. And again, thanks to the way that I've organized the columns and thanks to the checksum at the bottom, we can easily move things around, okay, across different sushi lines to make our lives easier, okay? So for example, what I can do, if I wanted to do this, is I could start with the plutonium fuel rod blueprint, and I could do the following. I can say, oh, I don't like the fact that the electromagnetic control rod and the concrete are on the same line. That means I have to split that using a smart overflow setup. That's a lot of work. I don't want to do that. What I'm going to do is I'm going to move the electromagnetic control rods from line 4 to line 3, okay? Like that. Boom. Okay? Now, all of these items are now on separate lines. Super convenient. But look, checksum is now incorrect. So I gotta go fix that. So we're gonna go down the list. We're looking for electromagnetic control rods specifically, so we can... This one right here, so we're gonna put this here. Okay. And then boom, checksum validated. So we just moved all the electromagnetic control rods onto a different line, okay? And because of that, I've made the designing of this blueprint way easier now, because now I can just pull one item from each sushi line instead of having to pull everything out from, you know, different lines. Okay, that's just an example of making my life easier. Okay. So yeah, and again, this allows us to build backwards for convenience purposes. So I can build backwards and go down the stack as I go and start reprogramming or moving things around. So this looks good. I don't have a problem with that. Okay. So yeah, this is kind of weird. This is the acid blueprint, and there's so yeah, this blueprint looks pretty bad. There's a lot of different things that we're pulling off the stack here. Holy crap. Looks pretty bad. Okay. We're pulling rubber AI limiters. So, yeah, wow. Oh yeah, so, okay. This is a bit convoluted. I'm gonna cheat a little bit here. What I'm gonna do is I'm gonna move internalize stuff on this line. Because this is essentially like an internalized line. It's being made and consumed in the same blueprint, so you don't have to worry. It doesn't interfere with the sum down here. Clears up some of the visual clutter. I think heatsink is also internalized. Never mind. Is there anything else that's internalized? I don't think so. I don't see anything else internalized. Yeah, and then we have to ignore the positive values because they don't. Not the problem. It's the negative numbers that are the problem. Yeah, there's a lot of stuff that is being pulled. Don't like. Have encased uranium cells. Have electromagnetic control rods, quartz. We have some rotors here, and then we have rubber daters and AI limiters. Okay, so this line is not being used for any. So I guess what I could. That frees things up. We still have a lot of stuff here. So we have quartz crystal, crystal oscillator, have AI limiter and rubber stator. So I'm using up all the lines here, and we still have a lot. We have 5 items being pulled. I don't think I can't meaningfully massage this any further because I'm still gonna have to pull extra stuff off of this, unfortunately. Yeah, this is actually going to be very hard to build for a blueprint because there's a lot of lines being extracted. What I may have to do is offload stuff, you know. Yeah. So that's just an example of me like having this incredible freedom and flexibility to move stuff around and still validate the math. Still validate the math here. To make sure nothing is over the limit, and yeah, everything looks good here. Okay. Alright, so I think I'm going to end stream here. Again, I apologize for that being super boring, but yeah, this gives us a tremendous flexibility now. We can start actually designing blueprints. Alright, I'll catch you on Thursday this week. Alright, take care, bye-bye.